Dear students, greetings from Dr. T. Senthil Murugan, Associate Professor, Department of IT. In this video lecture, we are going to discuss about unicast routing in Computer Network subject, Unit 3. Okay. In this video lecture, we are going to discuss about Week 10, Lecture 1, CDT28, Classroom Discussion Topic 28, Unicast Routing Protocol. Okay. So, what is Unicast Routing Protocol? What are the types of protocols are there? And we will take the example protocols and we will discuss in this lecture. Okay. So after completion of this lecture, student will be able to develop the routing table for all the nodes with minimum cost using distance vector. Okay, so if they will give the network, you can find that routing table for each and every node which is available in the network using the distance vector. Identify the shortest path for all the nodes to each and every node using link state routing technique. So the end of this lecture, the student will be able to do that. They will find the routing table of each and every node which is available in the network using distance vector routing protocol, and as well as the students will be able to identify the shortest path from each and every node to each other nodes through link state routing technique. So what is unicast routing protocol? Okay. A protocol needs to define its domain of operation, the message exchange, communication between routers, and interaction with the protocol in other domains. Okay. So before going to discuss about unicast routing protocol, you must be know how it is working. Okay. So before in unicast routing, three common protocols are there in the internet. What are those? First one, routing information protocol. Okay. So this routing information protocol is the example for distance vector algorithm. So we are going to discuss about distance vector algorithm. So it is based on the distance vector, the routing information protocol will work. Second one is open shortest path first. So here, this is one of the protocol. This will work based on the link state algorithm. And border gateway protocol, it is one of the protocol. It is also working based on the path vector algorithm. So in this video lecture, we are going to discuss about distance vector routing, link state routing. Based on this, we have to discuss about those protocol also. So internet structure. So normally we know that internet service provider will be there, users will be there, it will be connected, users can get the internet from the service provider. But how normally it is there? We can say that it's a tree structure. Okay. So it may be work with the single backbone. Okay. So this is the backbone to multi-backbone structure. So multi-backbone means multiple backbones will be there for different institution or different organization or different private corporations. It will be different backbone is there. Okay. But generally how we can say provider network. Provider network means internet service provider, ISP. Already we are discussed in our class internet service provider. Maybe any private companies. So in India we know that Idea is one of the service provider, Airtel is one of the service provider, okay, Geo is one of the service provider. They are providing the internet, so we can say that those are the internet service provider. So apart from that, customer network will be there, it is connected like this only, okay. So this is the internet, we already know about it. So provider, service provider have the backbones. So the provider taking the internet from the backbone, that the provider will provide to the customer network. So in between the peering network, peering points are there that will be connected to the some different backbones also. So there are several backbones run by the private communication companies that provide global connectivity. So already we know about it. So these backbones are connected by some pairing points that allow connectivity between the backbones. That only is shown in the figure. Okay, pairing points are connecting the different backbones. At a lower level, some provider network that uses the backbones for the global connectivity, but provided services to internet customers. Okay, so the providing the internet to the customer, it is taking the global connectivity of the backbones. There are some customer networks are there that is used the services provided by the provider networks. Okay, so as these three entities like backbone, provider network or customer network can be called the internet service provider or ISP. So they are taking the global connectivity from the backbone or provider network or customer network, and it will provide to the different level of users. Okay. So still how the hierarchical routing is there. So if we know the internet, then only we know that how the internet is working. So number of networks and routers are connected between different systems. So if we are using that, if tree level means it's a big size of tree, it will come. So how we can find that route from source to destination, how it is connected. For example, you are chatting, your mobile is connected with the internet, you are searching some data from Google. Google data center is there somewhere. So how your data center, your mobile is connected through internet. That is using the routing concept. So while we are going with that tree structure, we have two issues. One is the scalability issues, another one is the administrative issues. So what is scalability issues? That means size of the forwarding table becomes huge. Okay. So if one data is there, that will forward the information from source to destination. So in between many nodes may be there, but if all the information will be stored in the routing table of the source. Okay, so this routing table, if in case more number of intermediator is there, means more number of routing table also will be there. So what happens if in case it is huge, searching for a destination in a forwarding table becomes time consuming. So from this routing table, it's identifying the destination where it is there. So for searching it also, it will take time. So that is the scalability problem. Okay, while huge amount of traffic. So as the figure shows, each ISP is run by the administrative authority. So already we know that the figure shows that some authority will be there, like backbone will be there, provider will be there, customer services will be there. So they need to have control in its system. The organization must be able to use many subnets, okay, subnets and the routers as its needs. So if example we will take its W, we will use how many routers in how many switches for each and every lab. All the labs will be connected in the administrator block. Then the administrator have the control over all the networks. So like this, you think about it in the world level. It's very huge. Okay. So in hierarchical routing means considering the each ISP as an autonomous system. So individual internet service provider is there, no, like backbone or provider network or customer network, whatever it may be, those systems are considered as an autonomous system. So each autonomous system can run a routing protocol that meet its needs. So the autonomous system needs the routing protocol. So routing protocol is important part for finding the route from source to destination. For example, but global internet runs a global protocol, local internet using the routing protocol. Okay. So the routing protocol run in the each autonomous system is referred to as the intra-autonomous system protocol. Okay. So the routing protocol is there, no, this will be used in the autonomous system. If it is used means that is intra-autonomous system routing protocols or intra-domain routing protocol or interior gateway protocol IGP or global routing protocol is refers. So these are the intra-autonomous system, and global routing protocol is referred to as inter-autonomous system routing protocols. So we can say that inter-domain routing protocol or inter-autonomous system routing protocol or exterior gateway protocol. Okay. So these protocols are there. We will discuss with one by one. Okay. If autonomous system is there, okay. So in case we are saying that some service provider have autonomous system. So for example, each ISP is an autonomous system, we are saying. So when it comes to the managing network and routers under its control. Okay. So what we have to do, there is a size, different size is there. Small autonomous system, medium size autonomous system, large autonomous system. Okay, each system have autonomous number. So who will provide this autonomous number? By the ICINN. Okay, Internet Control Authority for giving number systems. So they will provide the 16-bit unsigned integer for the autonomous system. Based on that, it will be. So this autonomous system is not based on the number of system connected there. Okay, so how it is connected, according to that it will be classified. Okay, it is not based on the number of system is there, number of router is there. So based on that it have classified into class stuff autonomous system, multi-homed autonomous system, transient autonomous system. First one, what is we are going to discuss about, what is stuff autonomous system. Stuff autonomous system means only one connection to another autonomous system. Okay, so if the autonomous systems are there, different system means, so some systems may be connected. Okay, so example, it is connected like this. So this autonomous system, only one connection with other autonomous system, that is considered as a sub autonomous system. Okay, so you just remind it. What is the meaning of that? If it is there, that data traffic can be either initiated or terminated. Okay, it will send or it will receive. It is not forwarding. Okay, it cannot pass any datagram through it. Okay, so it may be the starting point or it may be the ending point. It is not acting as an intermediator. Multi-homed autonomous system. What is multi-homed? Same method, but more than one connection to other autonomous system will be there. Okay. So if, for example, this connection will be connected like this, many connection will be there. But even though it may be used for many connections, but it is not transmitting any data through it. Okay. It's not permitting to transmit the data. For example, multinational company. Some company may be in India, some company may be in US, some company may be in UK. So if you want to connect it, it may be connected, but this network is not providing the services for other autonomous systems. It is not permitting transfer the data through this network. So that is multi-homed autonomous system. So finally, transient autonomous system. What is transient? Transient means it is more than one connection will be there, as well as it is also allow the traffic. That means this will be intermediated for some other nodes. Okay, so it may be more than one connection, one, two is there, but this system will send the data, and through this network it will pass the data, or it will pass the data this way. So this network is considered as a transient autonomous system. So now we are going to discuss about distance vector routing protocol. What is distance vector routing protocol? In distance vector routing protocol, each and every node will maintain the routing table. In routing table, have information to all how to reach the all other nodes. So what is the distance that will be there? In each and every table, two address will be there, and then cost of the particular node will be there, and next, which is the next node, that is also will be there. So how it will be updated normally? You just think it's a small network they are given in the diagram. 1 A, B, C, D, E. So total 5 nodes are there. So this table, you will take the first column is 5 nodes. From each node it will be updated. So here A to B, 5 is there. So A to A itself there is 0 cost, no need to for any other node. B, so this B you just think A to B, so 5, cost is 5, we are updated. A to C cost is 2, we are updated. A to D cost is 3, it is updated. But A to E there is no direct connection, that's why we are kept infinity. Okay. So wherever there is no direct connection, we will keep infinity. This is the initial step, first step. Okay. So in the initial step, there is no path. So after that, what it will do? So each and every node will share their routing table to neighbors. For example, you will consider A routing table. So A will get routing table from B. So this routing table it will get, and it will check any path is there for some other nodes. Okay, it will compare the distance also. So with this available value, it will check. So A to 0, no need. Okay, here A table will check. A to A, no need. A to B, this is from like this. You consider A to A to B, A to C, A to D, A to E, like this you can consider. Okay, because this is the routing table of A. So A to B already 5 is there. So no need to update. Direct connection is there. A to C already direct connection is there. A to D direct connection is there. So through this, if you are comparing, it will extra value will come. So it is greater than already available value. So if it is less than available value means we can change it. Okay. So A to B, there is 0 is there. Here it is 5 is there. So we will keep 0 only. So A to C, okay, A to C already 2 is there. So now A to C how through B if you will go means 5 plus 4, 9 it will take. Okay. So here also we can add B value. 5 plus 5, 10. Here 5 plus 5, 4, 9. So it is compared with that, it is the less value. So A to D, here value is there, here it is not there. So but A to E, 3 is there. So 3 means already A to B 5 plus 3, 8. So what happened initially if you, after sharing this, it will update here 8 through B. Okay. So once it is getting the B table, it will update his routing table as 8B. Then after that, C will share this table to A. So from this, it will check A to E. So A to C already 2, A to E for C to E is there 4 value. So already infinity is there. So already 8 is there after updating B. Then now we are checking with the C. So what is the value? 2 plus 4, 6 is there. Okay. So what it will do? Already 8 is there. It is compared with this new value 6. So it is greater. It is less. So the less value will take and it will update like this. It will remove 8B. Okay. So it will remove 8B and it will update 6C. So through C it is 6. The value will be updated here. So after updating this third table, D also sharing the information. There is no information, so no update. So finally, what is the A table? After updating, so A, B, C, D, E is there. Okay. So here initial values also is there, same 0, 5, 2, 3. There is no changes. But E, we are getting that 6 value through C you are getting. So these are the direct link. That's why we are kept a hyphen. Okay. So this is a table. Like this, we can update. Finally, we are getting this tables like this. Okay. This is the distance vector routing protocol. So the routing protocol is classified like intra-domain routing protocol, inter-domain routing protocol. The intra-domain routing protocol have classified distance vector routing, link state routing. Now we are discussed about the distance vector routing. So after discussion this classification, we will discuss about one example for distance vector routing. Then we will discuss about link state routing with example of OSPF. Then finally we will discuss about border gateway protocol. So RIP, routing information protocol, it is based on the distance vector routing. Okay, so it is the intra-domain routing protocol. So already we know the classification. This is the intra-domain routing protocol. It is working based on the distance vector. We know that. So it is working based on the hop count. Okay, so first, since the router is an autonomous system, needs to know how to forward a packet to different network in autonomous system. So wherever any protocol it may consider autonomous system to have idea to reach the destination. Okay, so there what it is do RIP router advertise the cost of the reaching different networks instead of reaching other nodes in a theoretical graph. Okay. So instead of reaching network with the hop count, it will consider the different network. Okay, so it will consider only different network. Second, to make the implementation of cost simpler. Cost simpler means less cost. It will check from source to destination. Okay, so these many nodes may be there. So it will go like this. This is the destination, this is the source. So how many hops are there? So 3 hops are there in this way. So it may be another way. So this is another way. So here only one hop is there. So which is the shortest? So here number of hops are more, but distance is high. But here number of node is less, but distance is high. Okay, here distance may be less, here distance may be high. So in this situation, it will choose this route. Okay, so this distance is less, half count also less, distance also less means it is the better route to select. So see this diagram it is updated based on the half count. Okay, so initial network we don't consider because it is the sharing the information only. It is not getting and forwarding. But till last node, last network we have to consider. Okay, so for example, this router. Okay, so how many hops are there? Router 3 only one hop. It is connected with this network. So N4 is there. R3 is connected with N4. N4 is connected to R3. So one hop to reach the destination. So destination is N4. It will reach one hop. So from routing to R2, how many nodes are there? Here one network is there. Here one network is there. Two network it will cross. So two hop. Okay. So two hop. What are the network number? N3 and N4. From route 1, from here, if you are considered, so N2, N3, N4, three networks are there. Okay, so three hops are there. So we will take the length of the node from source to destination is 3 hops. Okay, this is a hop count will be used in the distance vector routing in RIP, routing information protocol. Okay. So for example, routing information protocol have three table already we know that. So three column is there in the routing table. First column for to address, next column is cost, then last column is which through which pointer we are forwarding. So but in RIP, three column table will be maintained. First column is address of the destination. Okay. Second column is address of the next router. Okay. So third column is cost between the router or destination network. Like that, three column it will be maintained and this will be shared to others. So based on the previous diagram, routing table, forwarding table for router 1. Okay. Forward table for router 1. You just see here. This is router 1. How many hops we want? If want to reach the destination, if you want to reach N2 means 1 hop. If you want to reach N3 means 2 hop. If you want to reach N4 means 3 hop. Okay. So you just remember this diagram, then we will discuss those things. So see here N1. So this is routing of R1. So how it is there? R1 router is connected with N2 network to network 1. So there is no next router. Only one router, direct connection is there. That's why we are saying cost of the hop is 1. But N3, after this N3 network only, that one more router is there, then N3 is there. Okay. So here, how many hop is there? Through router 2, 1, 2. So 2 hop is there. So in case another router, so router 3, via router 3, how many hops are there? So 3 hops are there. But from this router, it will forward through R2 only. R2 only, it will reach 3. So like that, each and every router have routing table. Based on the forwarding table only, it will forward the data. Okay. So RIP implement using the distance vector routing protocol. So you just refer these points. This is you have to follow. Okay. Instead of sending only distance vector, the router needs to send the whole content of its forwarding table. Okay. So only information, this is the next neighbor, like that it is coming now. Instead of that, it will send the entire table to the particular system. The system will analyze which is the cost simpler. Accordingly, the data will be transmitted. Okay, these are the routing information protocol. So this protocol steps are there, how it is working. This theory part you can refer your textbook. So how the routing table will be updated. Initially how it is, and after updating how it will be updated, you see here. So in case new R1, this is the diagram we will take. So initially R1 value, it is like this. It is connected with N1, N2, N3, 3 nodes. Okay, 3 nodes are there. It's connected with one hub count, directly connected with router 1. Okay, so in case this is the old route, how it will find the new route? So here in case, so R2 seen by R1. Okay, R2 seen by R1. What happened? So R2 is getting the routing table, forwarding table. This table is there, no old table. It will forward to route 2. So route 2 identify that. It will connect to route 1. These numbers N1, N2, N3 are connected with the route 1. Based on that, it will update. Okay, how it will update? So in case the direct link is there from route 1, N4 is one more router will be there. Here N4 is there, no? The router will be added. R2 will be there. So through R2, N4 will be reached. Okay. So through R2, N5 also reached. So here one network, here two. Okay. So after updating this R2 part, we can add N4, N5 in the route 1. Like that, route 2, route 3, route 4 will be updated. Okay. To see this diagram, you can easily identify it. So final data will be like this. Next one is the link state routing protocol. What is the difference between distance vector and link state? Distance vector routing protocol, each node will maintain the routing table. The table has the information about all other nodes, how to reach it with minimum cost. But in link state routing protocol, each and every node will maintain the entire network structure. Okay. So here node A is maintaining that structure. Node D also maintaining the same structure. E also maintaining the same structure. And B also maintaining the same structure like C also. So what it will do? It will take the structure and it will prepare the table, routing table. In this table, it's how minimum or shortest path from one node to all other nodes. Okay. So it will prepare the shortest path from each node to all other nodes. How we can do it? So first initially can using the Dijkstra algorithm for finding the shortest path. From that, it will be updated in the routing table from each node to each other node, how much distance will be there. So the Dijkstra algorithm will be applied for all the nodes to identify the shortest path from all other nodes. Okay. So simple example we will take. This is the diagram. So initially we will take the A route. So the first node we are applying the Dijkstra algorithm here. Okay. We will take the route A. So whatever nodes connected with A, that will be used here. B, C, D. These three nodes are connected with A. So simply we are connected with cost also. So compared with these three, the minimum value is 2. So the next visit node is C. So that's why C is in the orange color. So we are visiting C. After visiting the C, it will identify any other nodes are connected with the C. So here already D is over, it is not connected. From C, we are getting A only, no need. A to B, already B is connected with A, no need. So A to E, E is pending is there, then E is connected with this node. So after connecting, this value is 4, this value is 2, so 2 plus 4, 6, that will be updated. So from then we have to check which is the minimum value here. This diagram 3 is there, then 5 is there, 6 is there. So out of these three, 3 is the minimum value. Then it will come and check D. So D will be visited with the minimum value. Okay. So once D visited, from D any nodes are there, we have to check. If there is no nodes, so that's why we just keep and we will come for next step. From this network 5 and 6 is there. From these 5 and 6, 5 is the minimum value. Then we are visiting the B. So finally, from the B there is no node is connected. So directly the remaining node is 6. Finally, we are visit the node 6. So this is the link state algorithm to find the link to all other nodes from the particular node. So applied the digital algorithm, we are identified the link state diagram for root A. So like that we have to find all other nodes. That is link state algorithm. Okay. So YSPF is the example for the link state algorithm. What is YSPF? Open shortest path first. Okay. So this protocol is an open protocol, means that specification is public document. The document is common to all, anybody can use it. Here the previous diagram we know there is only network, there is no cost. Okay. So here we are given the cost for each network. This cost based on the performance of the network. Performance of the network means it may be the throughput, it may be the quality, it may be the quality of services. So high throughput, less delay, then very less packet loss, more delivery is there. Like that, some characteristics related to quality of service will be considered, and the cost value will be given like that. Okay. So based on that, it will be used. Okay. So in the previous diagram, they are given the hop count. Here they are calculate the cost value. So what is the cost between the source to destination? It's a diagram is same, but instead of hop count, here we are using the cost value. Okay. So OSPF also using the routing tables. The routing table also, when we are saying with the previous table, it is same, but there is no cost value. Here the cost value will be there. That is the main difference. Okay. So N1, it is connected to root 1, but the cost value is 4. Okay, like that we have to update the cost value in the routing table. Okay. So in other words, hop count will be considered as a cost value. There is link state database is there. So link state database will be used for finding the routing information from source to destination. So like how much cost is there, based on that it will be identified and it will be advertised. So in OSPF we have 5 types of advertisement is there: router link, network link, and summary link to network, summary links to autonomous system, border router, and external link. Like 5 is there. Just see the diagram. First one is the router link. So router link already we know stub link and transient link, which is permit the data